So this is my task 5.1. Basically, the first thing we had to do with this, we've got basically an animal class, and there's no inheritance used at first. So an animal can have a name, they have a diet, location, weight, age, color. I guess you could sort of use this to make various different types of animals, but the problem being that so when an animal eats, might not be the same for different types of animals. As we can see here, we've got make wolf noise, make eagle noise. Like, how would we keep track of what's what? Maybe we'd have to keep track of an internal string or something to keep track of what animal we actually got with a bunch of switch statements. It's not the neatest or most elegant solution. But then we created a zoo with inheritance. So this has got various different types of animals rather than just a base animal class. I mean, every animal in the zoo, is an animal. So every class does derive from the animal class. But we've got bird, eagle, feline, lion, penguin, tiger, wolf. We test them all here. So, for example, we can all expect an animal will have a name, diet, location, weight, age, color. But then there might be some extra things that are unique to certain animals, like a bird has a wingspan. Well, a tiger doesn't have a wingspan. And we're not, everything doesn't just, it's not like a flat structure. Not everything's just coming from the animal class. I mean, as the very base class it is, but certain things can be derived from the bird class, like eagle and penguin, both bird types. But they're not the exact same. Like a penguin can fly. A penguin can't fly, and an eagle can fly. So with the code, so say we have a method here, we designate it as virtual, and that means that it can be overridden by a derived class. So fly, some birds can fly, and then we can override that. Where is it? Fly, 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 fly. Here it is. We can override fly to act differently based on the class that's overriding it. But the most useful thing, well, one of the most useful things about this is that you can, it might be in the next part, but you're actually able to add a bunch of derived classes to a list. Actually, it might be the polymorphism task. Yeah, but you can add a bunch of base classes to a list, call a common function on all of them. I don't know, say for example we had, I don't know, everyone in the whole world making decisions, or every thinking thing making decisions. You could have a big list of, sentient beings, and then you could have like a like next decision function, and it would be very different based on the derived classes and what's actually doing it. But ultimately, that would be a base function that they all have in common. So the next task with this was overloading. So I believe this is where we got. Yes. So basically, when you have two functions with the same name, uh, overloading is where the compiler decides which function it's going to use based on the parameters passed in. It checks which group of arguments matches the particular method. So for example, same names, but if you called it and just gave it a string, it knows to use this function. If you called it and used the string and the integer when you pass the parameters, it knows that it's using this function. What else do we have for this one? Yes, we were testing what we would get out of these. So basically, what do we got? Which avoid A1 is M1. Okay. So if A1 is M1, it's fine. So what do we got? Part A. Okay, so if we create an A, a B, and a C, what do we expect to get? So this is straightforward. A.M1, A is M1. So the output of this should be A is M1, B.M1, B is M1. That'll be the output there. Part B. A equals new A, B equals new B, C equals new C. Right, let's check this. What's the first one? A, M2. So we'll get A is M2, B dot M2. And we'll get B is M2. C M1. We'll get C as M1. And calling C M2, well, we never overrode that in C. So we've got to go back to figure out. So C is derived from B. So we'll get B as M2. Right, so let's test it. Yep, just like I thought. That's the way it pans out. So yeah, I guess I'll just quickly prove that the other codes work. We got the main function. Oh well, we didn't even have any output for this one. What else we got? Okay, so William the Wolf, yep. So we can expect well, seeing as we pretty much followed the directions of the instructions, yeah, so that works as expected. Alright, next one. Yeah, so call this function, then it calls this function because of the parameters passed. Already did that one. So yeah, that's pretty much it for this one.